Okay, feedback mechanisms. And actually, I just copied the slide that I used earlier in this course to talk about feedback mechanisms to here. Remember what a feedback mechanism is where, and there are positive feedback mechanisms and negative feedback mechanisms. A positive feedback mechanism enhances the original change. A negative feedback mechanism will ultimately diminish or shut down the initial change. So, with regard to climate, I'm going to give you a couple examples of an assortment of feedback mechanisms, starting with a positive feedback mechanism. And this is how this would work. I've got these little flow charts to kind of talk you through it. For instance, remember, so a positive feedback mechanism ultimately conditions would lead to enhancing the original change. Let's just start here with the oceans become warmer. We've been talking most recently in this chapter about temperatures, global temperatures warming. So if the oceans become warmer, then we will have longer melt periods, and then ultimately our ice cover will decrease. And if our ice cover decreases, there will be less reflectivity. See, our albedo will go down, less reflectivity, and less reflectivity ultimately means that our Earth is going to absorb more solar radiation. If our Earth absorbs more solar radiation, then the oceans are going to become warmer. Then we'll have longer melt periods, we'll have less ice, we'll have less reflectivity, our Earth will the Earth will absorb more radiation. Okay, you see how this is a positive feedback mechanism? And as it's laid out here, we are definitely talking on a climate scale, not just day-to-day weather. Now, this is actually global warming, a negative feedback mechanism. Check this out. So, let's say temperatures of the Earth are rising, which I frankly believe that they are. As temperatures rise, that would increase the amount of water that would evaporate into the atmosphere. Okay, so water is going to go from being liquid on the Earth to being a vapor in the Earth's atmosphere. Well, at some point we've talked about that vapor ultimately condenses and forms clouds. Now, with this increased cloud covering, actually that will block some of the incoming solar radiation, and then it will have perhaps a net influence with blocking incoming radiation, it will make the Earth become cooler. See how ultimately these set of changes dampen global cooling is the opposite of global warming. So this is an example of negative feedback. Here is another cooling sort of scenario, and it has to do with aerosols. Aerosols, which quite often are ultimately a secondary pollutant from burning fossil fuels, they too can block, just like cloud cover, they can block incoming radiation and have a cooling effect. Now, the presence of aerosols, though, this cooling effect is localized, and it's generally short-lived because after a precipitation event, these aerosols are removed from the atmosphere, so they no longer have an effect. But along the lines of aerosols or pollutant aerosols, what you're looking at here, I don't know if you can see it very good, but it's a plume of aerosols that originated from China. So this is anthropogenic pollutants, and it's called the corridor of haze. Okay, and it can block incoming solar radiation, and it can have a net cooling effect on the Earth's surface. Now, I don't encourage us to go and put a bunch of particulates in the air to cool down our Earth, but it's complicated, isn't it?